This video is regarding finding a general solution of a differential equation. General solution means the solution has a constant c in it, and I will solve these three examples for you. The first one is dy dx equals to x times cosine x squared, and the dy dx is the same thing as y prime. I prefer to use dy dx because I know that dy dx tells me x is the independent variable. So what are we looking for? We have a y prime. We are looking for y. From y prime to y, we have to undo the derivative. Undo the derivative means we have to do the integration. So y is equal to the integral of x times cosine x squared dx, and then this is a u substitution problem because the derivative of 2x of x squared is equals to 2x, so the x will can't get rid of the x in front of the cosine. So we let u equals to x squared, so cosine is a composition function. We have x squared inside a cosine, so we let u equals to that, and then du is equals to 2x dx. 1 divided by 2x du is equals to dx, and then we do a change of variable. We will replace the dx with 1/2 x du. So y is equals to integral x times cosine u, and then dx become 1 divided by 2x du, and then you get rid of the x, right? So, and then you check the integrand, make sure there is no more x. So now you have a constant 1/2, you can take it outside of the integral, so you are really integrating cosine. So the integral of cosine is a sine. So you have y equals to 1/2, and then times sine of u plus c, and then all you have to do is you put the x back, so that is 1/2 sine 1/2 times sine x squared, sine x squared, and then plus c. Okay, so this is the general solution, and then you can just do one final conclusion. So y is equals to 1/2 sine of x squared plus c. You can box this and then write a name right next to it, and then this is general solution. What happens if you know what c is? So you need an initial condition to find the c. So when x equals to a number, y equals to a number, you plug in x and y to find the c, and that solution is called a particular solution. And then let's do the red one. Dy dx equals to x times e to the x squared. So copy the problem first. We have y prime equals to x times e to the x squared. So we have to find y. That means we have to undo the derivative by taking an integral. Y is equals to the integral of x times e to the x squared dx. This is another u substitution problem. So u is equals to x squared. Du is equals to 2x dx, and then the x will get rid of the x in front of the e. 1 divided by 2x du is equals to dx, and then we do a change of variable, so we replace the dx by the 1 divided by 2x du. So y is equals to integral x and then e to the u, and then the dx is 1 divided by 2x du, and then you can get rid of the x. So get rid of the x, get rid of the x, and then y is equals to 1/2 the integral of e to the u du. The integral of e to the anything is just e to the anything. So y is equals to 1/2 e to the u plus c, and then we put the x back. So y is equals to 1/2 e to the x squared plus c, and then there you go. Box that, and then this is my general solution. Because we don't know what c is. So if you know what c is, using an initial value, so let's say when x equals to a number, y equals to a number, and then you plug in the x and y, solve for c's, and then you put the c back to the general solution, and the general solution is now called particular solution. But the given condition, what x equals to and what y equals to, we call that the initial value. We have one more, so we have the yellow one, 2x times 4x squared plus 1. Okay, let's do that. So I'm going to copy the problem for you. So we have dy dx equals to 2x times the square root of 4x squared plus 1, and then this one is y prime equals to 2x times the square root And then we have to find y by taking the integral of the right hand side. So 2x, the square root of 4x squared plus 1 dx. So this one is another u substitution. It can be like integration by parts and something else. Since this is our first time doing differential equation, I prefer to keep the examples easy. So we let u equals to 4x squared plus 1, because I can see that when you take the derivative, you have ax, so the x will get rid of the x outside of the parenthesis. And then 1 divided by ax du equals to dx. So now I just review the u substitution for you. So do the change of variable. We have 2x and then the square root of u, right? The square root of u, and then the change of variable is this. So we are going to replace the dx with 1 over a 1 over ax du, and then the x will be cancelled. So the x will be cancelled. Get rid of the x, and then the 2 over 8 becomes 1 over 4. Alright, so y is equals to 1 over 4, and then the integral, square root means 1/2, and then du. So take the integrals of that, so you add 1 to it, that becomes 3 over 2. Reciprocal is 2 over 3, and then you add c to it, and then we multiply the fraction, so that becomes 1/2 times 1/3, so that will be a 1/6, and then the u is 4x squared plus 1, and then raised to the 3 over 2, and then plus c. So this is my general solution. So we call this general solution. If you are doing homework on paper in my class, I accept rational exponent, but if your instructor wants you to put this in radicals, then I will just write one more line. So the 1/2, the 2 is a square root, and then the 3 you can stick that with the 4x squared plus 1 plus c. But I don't see a reason of doing this, because the purpose of this problem is solving differential equation. It's not like handling the rational exponent. Okay, so that is the end of this video. If you think my instruction is clear and helpful, give me a like, share the video for me, subscribe to my channel if you are on your way out. Thank you for your support. I will catch you all in the next lesson.